It's a pleasure to be here. So for some more background to explain, why is the U.S. Department of Defense here speaking to this crowd? We're very excited right now about the possibilities of open source software and what it can do for our national defense, both from a classic defense security posture, but also economic security and control of our own supply chains, our own technology, our own information. I used to spend time as a DARPA program manager. You just heard Tejas was one of my colleagues for the last few years. I spent about 6 years there developing technologies from the most complex phased array antennas ever built to advanced transceiver technologies, embedded processors, information, new approaches to cryptography to control our information, and applications to the DoD using all those different technologies. Prior to that, I was actually the maintainer and lead developer for the GNU Radio project. So I was building the open source frameworks for doing what I like to think about as programming the electromagnetic spectrum. And I think that's an incredibly powerful concept that we've continued to try to advance and push on in building technologies that give us more access and control of that force of physics. So that's my background as far as why I'm here. But now I get to be the principal director for FutureG and 5G. And it's exciting that I get to be in this role because of a couple of reasons. One, it's one of the most important things that we're doing in the United States Department of Defense today. I'll get more into the details of why I think that. But two, one of the benefits that we have, that I've had in my career supporting the United States government and the DoD, is I get to focus on the warfighter. And that actually is a clarifying perspective. I don't have to worry about my annual returns or what the consumer wants. I need to make sure that they are protected and they have the best technology to support this country, support our nation and our ideals. So that helps us make decisions that affect the growth of technology, and as we've seen multiple times from my hat at DARPA, how we change the world. So thank you for bringing up the mRNA vaccine. Was a DARPA project started over 10 years ago to invest in that technology that has helped us to this day. So we're very proud of that fact. So I'm here to talk about our investments in 5G and then where we're going with what we call FutureG. Right? It's not just about next G, it's not about 6G, it's about looking into the future continuously and making sure that we're prepared to take advantage of it and to help lead in that technology development. So we started this initiative a few years ago when we were blessed with with support of the United States Congress to think about how the Department of Defense would engage in and lead in 5G rollouts and 5G developments. So we took that money and we invested in 3 key areas of funding. The first one is how do we accelerate the deployment of 5G technologies? And for this one, we put over $600 million into creating 5G capabilities at US bases. So military bases from Air Force, the Marine Corps, Navy, and the Army. The icons you see up there are different, what we were thinking of as dual use technology areas that we could invest in those base experimentation platforms that would help lead the markets and the technology developments in the markets when they were more mature and those markets were available. So thinking about this from that dual use perspective, which is really critical to our perspective on how we use technology, how we want to use commercial technology in the DoD. Instead of spending a ton of money to develop our own exquisite capability, like we've been doing for many, many years for many of our platforms, we're still going to do that for very specific cases and specific needs. But when it comes to communications, we realize that over decades of investments, we were supporting our unique singular capabilities. We weren't really solving the problem of a resilient, reliable, ubiquitous communications enterprise. Why? Because it's really, really hard. And the industry is helping us overcome that problem, so how can we pull that in? Similarly, if we're going to rely on commercial technologies, we have to make sure that we have a robust and supportive commercial market that exists out there. So thinking of these dual-use technologies is beneficial to our national economic security. It's also critical for our ability to continue to absorb those technologies and pull them into our use cases. So we wanted to keep that in mind, that we wanted to make sure that this was a commercial environment that we could continue to support. So we are investing heavily in spectrum policy, spectrum initiatives, AR, VR. How do we use that, again, support training, telemedicine, capabilities that support the warfighter. We're looking at things like stand-in forces for the Marine Corps. This is a big push from the Commandant of the Marine Corps, and it's going to need a lot of automated technologies in order to support those, the ability for the Marines to move and survive. And we're also looking at logistics, right? Many people here may understand this, how important logistics is. It sounds really boring. It's what wins wars. So we need to make sure that we're taking advantage of all of the capabilities that we have in this technology to support the most complicated logistics and supply route problem in the world, which is moving the US Army anywhere it needs to go. So with that, we've been investing in these bases. Most of those test beds are now up and running, and we're starting to run through a lot of the experimentation there. So we have some really exciting work going on there, and we have seen how this has affected the community and the technology development. The other aspect, and I'm going to dive into this much more in my remarks on FutureG, is the security aspect. It was mentioned in the panel just now, how are we securing 5G? One of the problems that we have is we often pull in commercial technologies into the DoDs who've been doing it for many years. When it comes to pulling in commercial technologies that manage and move our information and integrate with commercial networks around the world, it changes the level of concern. It changes the threat vectors. And why? Because if we can't trust our information, nothing else matters for what we do. So securing this technology, making sure we understand the security, we understand the risks associated with the security is super important. And so we have an entire effort dedicated to working on securing this from supply chains, from cybersecurity, from exploitation from a radio frequency perspective. And then finally, we initially started looking at this, we called Innovate Beyond 5G. So this was looking at the next generation of technologies and what do we need to do to invest in those, where do we need to put our investments to help overcome some of the critical technology gaps today. So that's become our advanced research group and is leading us into the FutureG world. Now, part of our work here, those are the three big buckets of our investments. We do recognize that the United States is not always the leader in everything, and especially in this world, there's so much mental acuity and capabilities and technology developments that exist around the world, and so we want to be able to engage with those partners and make sure that we're working together to create this technology that we can use to support our information operations. So, diving into each of these just a little bit more, I'm not going to spend too much time on this slide. There's a lot of words here, but there's a few things that I want to point out that I think are critical here. One, promoting technology development. We are looking at open architectures. Right? This is really important to us. So Open RAN in the O-RAN Alliance, we've been engaging with them. We've been engaging in that perspective. And I'm even pushing more from my backgrounds in the open source world, pushing more, not just open architectures, but open source reference models in order to support those architectures and prove them out, validate them, and make sure that they're creating that supply chain vendor diversity that we need for our supply chains. I also think that this is incredibly important to workforce development. If you look at the telecommunications industry in the United States, we are dramatically losing our workforce. It's gone down significantly since the 3G era, and we haven't really seen a bump up even with the excitement around 5G. Now, 5G is an interesting information technology problem as much as it is a telecommunications problem, but even still that workforce development is critical, and I think opening up access to the tools and the technologies underneath that underlie them is one of those ways that we're going to help reinvigorate as we invest in our workforce development. We're also talking about the security model here. So cybersecurity and zero trust. This is when I talk about open source again and open access to these systems and networks. We're doing the same thing with our cybersecurity and our zero trust approaches. If you haven't seen it yet, the Department of Defense Chief Information Officer has released their strategy on a zero trust architecture for the DoD. You look at that, again, it is an observability scope of all the technologies that need to go into place to hit all the different pillars of zero trust. I have a bit of a background in the encryption world. As I mentioned, some of the work that I did at DARPA. You don't trust an encryption algorithm that's not published, right? You protect the keys, we protect the data, but we want to make sure that these systems are open and auditable in order to actually improve our ability to secure them. So lots of different key points on this slide. But I want to finish up talking about the 5G work by just saying that we have a lot of thrusts here, a lot of efforts going on here. We have a plan to develop that technology and transition that technology, including some of our special projects like what we have at, what you just saw from Tejas Patel at DARPA, investing in those key, really innovative approaches to network security. So that's our portfolio in the 5G world. So what I want to talk about next is just go on a little bit about what I care about when it comes to FutureG. So looking beyond what we're currently doing with 5G, and it all really goes back to security. And I often am at the point working with leadership within the Department of Defense, within the US government, when people say, Tom, are you going to secure 5G? Or you're going to secure FutureG, or secure our networks? And I have to break the news to them because the answer is no. Because security is not just a hard problem, it's an impossible problem, right? If you're an attacker, you get to be right once, and you're a hero or a villain, depending on which side of that coin flip you're on. If you're a defender, you have to be right 100% of the time, and you're facing mathematics that tells us that you can never be right 100% of the time. So what are we doing here? We're trying to make security more robust, and we're trying to make these systems as resilient as possible. And that's when I look to the open source world again. Right, so I talk about open, transparent systems for security. And here I think that probably gets some nods of the head saying, of course, in the DoD, it's an education of how we actually make that happen. And again, I go back to, you don't trust an encryption algorithm that's not published and has been beaten around by the mathematicians around the world for a while to make sure it's secure. So we're pushing towards this open source nature, and our work with the Linux Foundation is really exciting for us. I've been working with Arpit and the team here for many years, establishing the relationships and trying to build towards solutions that are modeled on this principle that open source is going to help us with security. And it's critical that we have partners like the Linux Foundation, because the security doesn't come by just declaring something open source. It comes with a lot of hard work. And it comes with a governance and management structure that we can put on top of these projects that allow us to continue to push on securing systems, making them more transparent, making them more auditable, but responding to attacks when they're observed, and rolling out patches quickly, and managing the ecosystem in a way that is that allows us to respond to this incredibly difficult challenge of making sure our systems are secure. So that is one of the critical areas that we're talking about. The other way that we're framing this is 5G was about a technology push, right? It was 10x more data, faster data rates, 10x lower latencies, 10x more devices per area. Those are interesting goals, but by themselves, I don't think they're sufficient. They were technology leaps to say, we can do this, and we're working on that. And that's what's exciting about 5G, is it's giving us a technology leap ahead, and more capabilities, more resources on the network than we actually know how to utilize right now. So when I come to think about FutureG, specifically like just thinking about the 6G world, you may hear some people talk about, well, we did millimeter wave in 5G, so therefore we have to do terahertz in 6G. And I look at them and I say, you know, one data point isn't a trend. Terahertz is an interesting technical challenge, but it doesn't excite me. Right? We have so much room to grow with the resources that are available in 5G from the technology perspective. What we're missing are the markets that we need to support, the technology of those edge devices. We're still having a hard time finding 5G-enabled edge devices. We want a whole IoT system that's controlled by 5G. Right now we have to tie all of those things into a cradle point or another, or twist it somehow into the 5G network. So we're still missing a lot of those core capabilities at the edge. We're missing things like privacy and security. I think those are critical technologies that are values that we can input into the standards and into the technology world in order to make sure that our information, thinking straight from the DoD perspective, our information is protected, is private, and is maintained and managed and trusted. I think that has a great dual use case for the rest of the civilian world and our consumer technologies to make sure you're protected and your privacy is maintained and controlled. So when we're talking about this open source, again, as an education to the DoD and the workforce, we need, what I look at is 4 distinct points. Opening up our systems are going to increase capabilities. One of those capabilities is the RAN intelligent network, the RAN intelligent controller, the radio access network intelligent controller. An acronym with an acronym are really hard. The RIC. So the RIC is going to allow us to have real-time and near real-time control over our radio systems and over our networks. That's an exciting possibility for innovation. We're looking at this as ways to help us minimize energy consumption of our systems. Power usage is one of the critical costs of running our networks. From a warfighting perspective, it's diesel, it's fuel, or it's batteries, all of which become a supply chain problem unless we have systems that we can operate more effectively there. The RIC will also help us innovate on other optimizations of resource utilization at the ground level. If you think about the amount of effort that a mobile network operator puts into optimizing their solutions, their networks to sustain millions of users simultaneously on their networks, it's impressive. But it's a very different scenario than if you look at what a Marine stand-in force might want to operate, where they're moving around continuously in fairly small unit sizes. How do you support that model with by using consumer technology? It's going to be by developing our own algorithms and by using our own data to support those unique models. So added capability is number 1. Number 2, I think it's going to improve our innovation cycle. I look at, I remember the days growing up in the early days of the internet, where we were using technology like Berkeley sockets and the, I think kernel version 2 something was what I started with back in 93, 94 time period, of understanding the internetworking capabilities that were coming online through the internet. I'd like to see that innovation space happen as we are bridging our cyber and physical worlds together more and more through things like AR, distributed systems, sensor systems, quantified self. It's an innovation space that is ripe for new ideas, new markets, new entrepreneurs. The ability to open this up and allow that capability to happen is critical. The third point, though, back to security, because that innovation space needs to take security seriously from the start, embed those principles into it, and I think we can start to do that. I think we've seen, while it was exciting in the 80s and 90s, we also missed some of those critical ideas early on. So 3 is our security approach, as I've talked about a lot. And 4, back to that workforce development. I think that this is, again, critical for us. I think it's critical for the DoD to make sure that we have an educated and trained workforce as we have an educated and trained fighting force. Technology and information are going to be our ability to have decision superiority. Right? How fast and how accurate can we make decisions? Can commanders make decisions? It's all going to be based on our information capabilities. And so pushing that out and making sure that we have an educated workforce is critical. So those are some of the principles that I bring to what we're doing with the DoD push into 5G and FutureG. And I want to wrap up by talking about one of the great opportunities that's coming out right now. You've all probably been paying attention to the CHIPS for Science Act. Part of that money was given to the DoD, where we are going to establish an open technology commons idea, creating national hubs for semiconductor and microelectronics research. So we're having our industry day in downtown DC on December 7th and 8th to give you a better idea of what our intention is for how these hubs are going to support this technology commons, what it's going to do for us in the DoD, how we're going to invest in this around the country to support, again, workforce development, technology development, innovation capabilities. All this goes together, mixing what I just talked about in FutureG with the CHIPS Act. So one of our areas of investment is going to be in 5G, 6G under that funding. So that's going to be a really exciting future for us to reinvigorate our microelectronics, our semiconductor industry, all geared, or at least partially geared towards my vision for how 5G and FutureG impacts our economic security and our national security. And with that, I'll take my bow and thank you very much.